Good morning and good afternoon, everyone. Today, I am excited to share with you our recent research on metagenomic insight into enhancing protein content and digestibility in jack bean or Canavalia ensiformis tempeh and reliving microbial dynamics during fermentation with the authors Pira Putiarlina, Muhammad Jali, Robiandoyo, Siti Nurmila, and Marisa Melani. Indonesia challenges in meeting protein needs that low protein consumption needed for growth and development. Animal protein is so expensive and source of soy are scarce and rely on imports. Let's start with a brief overview of jack bean. We know that the name is Canavalia ensiformis, that this legume is known for its high protein content, but also presents challenge in terms digestibility. Jack bean protein to 22.8 and 35.3%. Productivity in Indonesia is very high, 3.9 until 4.6 tons per hectare, and prices that are quite affordable and complete amino acids. So if we make some product from jack bean to tempeh, it's more nutrition. Tempeh making is the process of soaking bean, cooking, inoculating with mold and fermentation. In soaking bean is one of process that have an improved protein. Second process facilitated the release of seeds, present of bacterial growth and increased nutrition and reduce anti-nutrients, especially increased nutrition of protein. And fermentation is changes in amino acid formed during the fermentation process due to an increase in free amino acids. Protein hydrolysis occurs and enhance the functional value of protein. So, if we make a jack bean from tempeh has potential as inhibitory and a source of bioactive antioxidant peptides. Material and methods: process of making the tempeh from jack beans and insulation jack bean tempeh hydrolysis. And we analyze physicochemical properties of jack bean hydrolysis. There are protein content, protein digestibility, degree of hydrolysis, protease activity, and identification microorganism with petagenomic analysis. Crude protein content of various starter mold concentrations. From the figure, we look that in a column concentration, 1.5% higher crude protein. So the concentration of 1.5% was found and to be based on the optimal physical and chemical characteristics of tempeh, especially its crude protein, crude protein, digestibility, and activity protease. So we move to make a tempeh and we analyze physical chemical profile. First, crude protein, jack bean, tempeh hydrolysis. From the figure, we saw that 36 hours fermentation time is highest protein hydrolysis result and was significantly different compared to other treatment. So we can conclude that 36-hour fermentation is growth phase of the mold. So nutritional value, especially crude protein, is higher in the phase of growth period of Rhizopus agrosporus. And we move to protein digestibility. We show that 36 hours has a highest protein digestibility. At 36 hours per fermentation, the results show a significantly higher digestibility, where the protein was able to be digested and utilized in the small instance in the digestive system as an in vitro hydrolysis. And degree of hydrolysis and protease activity is two process to look hydrolysis and activity protease to hydrolyze protein. The results show that degree of hydrolysis obtained in 36 hours of fermentation was significantly different compared to other fermentation duration. And also protease activity, 36-hour fermentation period showed significantly different result. So it showed that In the 36-hour fermentation, the degree of hydrolysis is the percentage of peptide bonds in tempeh that are released due to hydrolysis process from protease activity. So we looked at microorganism profile of tempeh and starter mold as metagenomic, and in A, bacteria show that mold tempeh and tempeh is so different, especially on bacteria Bacillus. Tempeh has Bacillus higher than mold tempeh. We looked at in fungi, it's a same dominant Rhizopus in mold tempeh or in tempeh. We show that phylogenetic tree, we saw that firmicutes on tempeh higher than mold tempeh, especially Bacillus, Lactobacillus, and Weissella. That there is potential to improve nutritional quality, especially protein on the tempeh. And also in proteobacteria, especially Klebsiella is dominant than mold tempeh. Klebsiella is one of dominant bacteria, contaminant bacteria, but it can uh, give nutritional value of them, especially vitamin. On fungi profile of tempeh and starter mold is same, that they are dominant rhizopus microspores that have from mold tempeh or tempeh. Conclusion: the characterization of protein hydrolysis during the fermentation process of jack bean with Rhabdima mold significant effect on protein content, protein digestibility, and degree of hydrolysis. The fermentation process and the concentration 1.5% per 36 hours show significant result towards an increase in protein content and high protein digestibility. The authors declare that there is no conflict of interest, and we would like to thank you to Rector Universitas Pajajaran and the Ministry of Education, Culture, Research, and Technology of Republic of Indonesia for the support the research. Thank you.